Today we're gonna focus on basically study unit 4. So gonna look at a lot of um, different um, techniques of probability. Um, then also on Sunday we will do study unit 5. So in today's session already, there will be some of the study unit 5 info. So, but mostly it will focus on study unit 4 of the probability. So let me quickly just do this. And as always, I will again share the whole pack with you after the session, so that we so that you have it. Okay. So let's start. So again, you will see some of the questions are from previous exam papers. Some of it is from previous assignments. So in this one, they tell us that a group of 150, so they give us the total CEOs is tested for personality type. So we're looking at a type A and a type B. And then we get it that they want us to look if there is differences between the men and women for type A and type B. Then they say if one CEO is selected at random from a group, which one of the following statements is correct? Okay, important, correct. Okay, so let's first see. The easiest one normally is if we look at one that we only need to find out the probability of one thing, so the probability of the woman. So it would be 19 plus 11. So probability of woman would be 50 divided by 150. And just again, reason why I do this one first is because because it's normally the easiest one to work out, and hopefully one can get lucky in the exam maybe. So 50 divided by 150 is equal to 0.2. So unfortunately, that one is not correct. Then we can look at probability W and B. So probability of W and B is 11 divided by 150. And we should have actually done that other one first. 11 divided by 150 is equal to 0.073. Okay, which is actually correct. Okay, let's just event woman and type A personality is mutually exclusive. Woman type A. So if that was a 0, then it would have been mutually exclusive. But there is 19. So 19 out of 150 would have given us a number. So that's why woman and type A is not mutually exclusive. Then probability of male given probability of B. So just remember we write it nearly as probability of M and B. So that's always the shortcut, probability of it to divided by the probability of the last one. Okay, so that will be probability of M and B, probability M and B, so that's the 42. And the probability of B, okay, so now we needed to add that up again, is 53. So 42 divided by 53, let's see what is that, 0.7925, which is actually that one. And then the last option, probability B given M. So it's still probability of B and M, which is still 42. So it doesn't matter how you look at it. If you look at it M and B, it's 42. If you look at it B, M, it's also 42. And that divided by the probability of M. Probability of M is 120. So that will probably be then the 0.35, but let's just look. 42 divided by 120, 0.35. Okay, so what I did again, basically, I started with the nearly easy ones. So the ones that I normally would think is easier to calculate. So I would normally begin with that one. I missed that. And then I will start looking at things that I need to work out. Okay, so that is when we get a table, and also I did not from the start nearly started completing all the numbers. Again, it does take time. So for that 11 over 150, we didn't need any additional information. So nearly also a learning for you guys when you write the exam is if you need to complete a table or need to complete any information, let's go through some of the options before you start completing, because again it does take time away from you needing to also look at the other questions. Okay, so this one again, and it's a bit blurry, it was taken from one of the previous assignments. So they tell us there's 800. Here is a number missing, and nowhere is totals, but we at least know that the total is 800. Okay, so I would first look at a few things. So I would check Vents High School and Les are not independent. So need to work out something there. The probability that a random chosen learner is high school, Les, okay, so that is a combination. The events less, between, and that are complementary. The events primary school and high school mutually exclusive. And the probability that a random chosen learner. Okay, so I would first look at nearly question C and D, and they want which one is incorrect. So the events less than 3 kilometers, between 3 and 6 kilometers, and greater than 6 kilometers are complementary. Okay, so that is correct. So remember, complementary when it was only two. So if probability of A was equal to 0.6, then the probability of the complementary was equal to 0.4, so that it always needed to add to 1. So here we have less than, between, and greater than. So all of those probabilities in the end will add to 1. So that means they are complementary. Okay, so if there was 6 of them, the same. The probability will always add to 1. And because of that, they are complementary. Okay, but we're looking for the incorrect one. The events primary school and high school are mutually exclusive. Okay, so you can't be in primary school and high school at the same time. So they are mutually exclusive. So that did not solve that we need not to work out anything. So then let's just start at the top one. So the events high school and less than 3 kilometers. So basically that are not independent. Okay, so for something to be independent, the probability of A times the probability of B needs to equal the probability of A and B. Okay, so that is, remember, that is the rule for being independent. Okay, so the probability of A, the high school, so now we need to start adding up. So 48 plus 112 plus 160 is 320. Okay, so the probability of A is 320 divided by 800. Probability of B, so that's less than. So we also need to now work out that. So let's quickly see. So I would say 800 minus 320 minus 240 minus 168 will give me that. So that is 72. But let's also just check. So 72 plus 48 is 120. 168 plus 112. So that is 280. And 240 plus 160 is 400. And if you add all of them together, you do get the 800. Okay, so the probability of less than 3 kilometers is 120 divided by 800. And let's see, so if we then work that out, 320 divided by 800 times 120 divided by 800 is equal to 0.06. The probability of A and B, so that is 48. So let's check 48 divided by 800. What does that give us? 48 divided by 800. Okay, it is equal to 0.06. Okay, so that first one is, oh, I'm looking for the incorrect one. Oh, okay, so, sorry, the events high school and less than are not independent. Okay, so it is the wrong one because they are actually independent. Because we worked out that the probability of A and B is equal to the probability of A times B. Okay, so there we have worked out the independence of the two. Okay, but let's also just check the others. The probability that a random chosen learner is in high school and travels less than 3 kilometers from home is, okay, so that we actually worked out the 7 over 48 divided by 800 is 0.6. So we actually have 0.06. And then the probability that a random chosen learner is in high school is 320 divided by 800, which is 0.4. Okay, so again, what I would do if this was an exam question, I would just quickly read through the options. Then I will check if there's anything that I don't need to work out any sums. And then nearly one just needs to start at a point. So unfortunately, it's not like this was now that there was the easy one that is the incorrect one. Unfortunately, then one just needs to go through the process until you identify the wrong one. Okay, so we've got the same information again. So just showing how they, and I think the next one as well. Yeah, just showing how they can ask it differently. So again, remember, there will be like 2 or 3 different questions that will be floating around in the exams. So there are, I think, 3 different exam papers. So this is a typical example of one question that can be asked just in a few different ways. So in this option, consider table 2.1. Calculate the probability that a random chosen learner is either primary school or travels more than 6 kilometers from home to school. Okay, so probability primary or greater than 6 kilometers. Okay, so remember then our formula is probability of primary plus probability of bigger than 6 kilometers minus the probability of the ant. Okay, so that is how the traditional OR function looks like. So probability of a one plus the probability of the other one minus the probability of the ant. So yes, we had it there, but let's just sum it up again. So 72 plus 168 plus 240. So the total of primary school is 480. So that probability is 480 divided by 800. Plus the probability of more than 6 kilometers. So if we add those together, it is 400. So 400 divided by 800. And then we need to subtract the one that is the double count, which is the 240. 240 divide, let me just rewrite that. The 240 divided by 800. Okay, so if we work out that, 480 plus the 400 minus the 240, we get 0.8. Okay, so 480 divided by 800 gives us 0.6. 0.6 plus 0.5 is 1.1. Then minus 0.3 gives us the 0.8, which is then option B. Okay, so when we need to work out the OR, remember it is probability of the one plus the probability of the other one minus the probability of the ant. Okay, so then they have given us exactly the same, but now they just ask us something different. And you will see the numbers have changed slightly. So there's still a 0.61. That's nearly the only one that's a duplicate. Okay, so consider the table again. Calculate the probability that a random chosen learner travels between 3 and 6 kilometers given that they are in high school. Okay, so what's the probability of between 3 and 6 and high school? Remember now that is how the given formula works. The probability of the ant, remember where we did that, the probability of the ant divided by the probability of the given, which is the probability of high school. So the probability of the ant divided by the given, and they given high school. So probability of the ant is 112. 112 divided by the probability of high school. I think that was 320, but let's just quickly add those together again. 48 plus 112 plus 160. Okay, so that have given us 320. So that would be what we will work out. So 112 divided by 320 is equal to 0.35, which is option D. Okay, so the same information, they just ask us to work out something different. So in this one, just remember when we have original, I think in the study guide, probability of A given B, it's always written as the probability of A and B divided by the probability of B. Okay, so when we just quickly look at this again, we needed to check for travel between 3 and 6, given that they're high school, so 3 and 6 and high school. And the given is at the bottom, so given high school. Okay, so that is how we got to 112, which is the and, divided by the probability of the high school, which is the 320. Okay, so with one data set, they basically have given us 1, 2, 3 different questions that they can ask you. Again, only one of them will be asked, so it's not that you will get 3 questions on probability. So you will get 2 questions at the most on probability. So again, they will nearly ask something like this and then ask a different type of probability question as well. Okay, so let's look at more examples. So here they basically looking at a lot of independent, mutually exclusive types of questions. Okay, so if we look at this one, we get information and they ask us if events AU, okay, Australia and female are independent. So there we will need to work out again probability of A times probability of B should be equal to probability A and B. So remember that is the independent one. So we probably will need to work out 1 or 2 of those questions. But let's just for interest sake look at 3, 4, and 5 as well. So events UK and female are mutually exclusive. UK female. Okay, so if that was 0, it would have been mutually exclusive. But there are people there, so that one is incorrect. The events male and female are not mutually exclusive. Okay, so in this instance, you could only be male or female and not both. So that is sorry. So that is also not correct. And then if events UK and female are independent, then UK and female is equal to 0. And again, that is not right if events UK and female are mutually exclusive, then UK and female are 0. Okay, so I nearly thought those three are going to be wrong, so that they want us to work out this one. So let's look. Events AU, so there's 102 of them. Over 580. And female, 260 females. And so if we work out that answer, 102 divided by 580 times 260 divided by 580, I get a rounded off number of 0,079. Let's check what is probability of that. So probability of, what was it, Australia and female. So it is for 52. Let's check what is 52 divided by 580. Fifty-two divided by 580 is equal to 0,09. So those two are not equal, so they are not independent, so that's also wrong. So option 2 will be correct, but let's work that out. So UK and female, so let's look at UK. 319 divided by 580. Female we now know is 260 divided by 580. And that should then be equal to female and UK, which is 143. Let's hope this one is at least correct. Okay, so 319 divided by 580 times 260 divided by 580 gives us 0,25, and 143 divided by 580 also gives us 0,25. Okay, so it is then true that the UK and female are independent, because we've showed that the probability of UK times the probability of female are the probability of UK and female. UK and female. Okay, so they are independent, and that's also why they were not mutually exclusive. Okay, so we are focusing a lot nearly on independence, mutually exclusive, but again, I think that is quite important, because we will get a question or two in the exam. So you will get something like this in the exam. So it is important, again, that we look at it. Okay, so again, same data set, a different question. So, and you can nearly, we don't always need extra questions, you can nearly look at the data set like this, and you can work out what is the probability of Australia, what's the probability of New Zealand, what's the probability of UK, what's the probability of female, what's the probability of male. Then you can practice and say, well, what's the probability of Australian female? What's the probability of New Zealand and male? So sometimes one of these data tables is actually quite nice just to actually test a lot of the things that you can get in the exam. You can also then say, okay, but let's test more for myself. Is New Zealand and male independent or not? Okay, so you can use a table like this and just play around and see what you get. But let's look at the questions that they've asked in this one. So probability, which of the following statements is incorrect? Okay, so first, now again, the incorrect one. And with incorrect, let's also check. Okay, so that's probability of one thing, probably easier to work out. Okay, there's ands, might also be easier. And okay, here's a given, so a bit more difficult to work out. So let's first do the first one. So probability of male, 320 over 580. And they say, well, that's equal to the probability of UK, or very close. So if you round those two off to 2 decimals, you will get the same, but let's see if it is equal to 0.55. So 319 divided by 580 is 0.55. So that is correct. Unfortunately, looking again for the incorrect one. Probability of AU and female. AU and female. And probability of AU and male. Okay, again, very close to one another with numbers. So if I round it off to 2 decimals like they do, 52 divided by 580 is 0.09. 50 divided by 580. Again, remember only 2 decimals is also equal to 0.09. Okay, so that is also correct. Okay, then probability UK and male. Probability UK and male. So that is 176 divided by 580. Which is equal to 0.3. Okay, so as I thought, would be one of the more difficult ones. Okay, so probability of UK given male, so it's the probability of UK and male divided by probability of male. Okay, so we have probability of UK and male 176 divided by probability of male 320. So if I work that out, 176 divided by 320 is equal to 0.55. Okay, so we basically had to work out everything to get to the last one. So let's just do that here. Probability of UK and female, or given female, so UK and female divided by probability of female. So UK and female, 143 divided by female, 260. Okay, so there one can definitely see that is wrong. So that also going to be 0.55. Let me just check that again. So 143 UK and female, given female, so 143 divided by 260. Yes, also 0.55. Sure, okay, so there's a few 0.55s in this setup. Okay, so yeah, again, I looked at the easier ones for hopefully getting one of those as incorrect. Unfortunately not. So yeah, it's not that there's been a quick answer to this one. One needed to go through nearly all of the questions to get to it. Okay, but again, the same data, just asked a bit differently. Then you can also get just a question. So I've added that formula just so that you have it, just to make it always simpler. But if we look at this question, now they only give us the probability information. So no tables, nothing like that. So you need to also, well, need to know it, but it is open book. So it's not that you need to know it off by heart. You can have it on a formula page. You can have it in your notes. So they're asking us to consider events A and B, which are mutually exclusive. And you need to work out what's the probability of A or B. Okay, so the probability of A or B, as we know from the formula, is probability of A plus probability of B minus the probability of the AND. Okay, so that's my shorthand for that. So probability A or B, probability of A, 0.35. Probability of B, 0.65. Minus probability A and B. They tell us events A and B are mutually exclusive. So if it's mutually exclusive, the A and B is equal to 0. So then my probability of A or B is equal to 1, okay, which is option 2. Very rarely that we get something like this. But again, you could have said definitely not option 3 because we can't get a probability more than 1. So that was already nearly one that you could have excluded from the options, but never exclude one. and also never exclude 0, because it can be, like we've now shown, you can get 0 and you can get 1 as a probability. So just be, again, on the lookout. Here they told us that it is mutually exclusive. So by seeing that it is mutually exclusive, the A and the B is equal to 0. So just that is what they tested in this one. So the next one, if you can follow the trend, will probably be independent. Okay, so now we get the independent question. Again, just have that formula up there. So for independence, still the same formula of a probability of A or B. And we still need to work that out. So probability of A plus the probability of B. But then the probability of A and B for something that is independent, remember that is the probability of A times the probability of B. Okay, so again, options can't be 1.22, can't be more than 1. So probability of A is 0.35. Probability of B is 0.65 minus the probability of A times the probability of B. And so we know that one is 1, but we need to subtract something. So 0.35 times 0.65 is 0, and let's just see all the decimals. So let's go to 4 decimals. Just check my calculator. Got it. So 0.35 times 0.65. That is 0.2275. Okay, so if they ask us what is the and, there is the answer, but they want us to find the or, so it is 1 minus that. So we sit with 0.7725. Okay, so just again, they do give us that option, so just be careful when you do it, that again, you don't work that out and you see an option and select it. But again, they could have asked us what is the probability of A and B. And then what they did with option 2 was to say 1 plus that would have given you the option 2, but you can't have a probability more than 1. Okay, so again, just going through the steps of if something is mutually exclusive and if something is independent, because that again is for me the most important 2 concepts in study unit 4, and then obviously to use your contingency tables and those kind of things. Okay, this also, as you can see, comes out of a previous assignment. So which one of the following statements is incorrect with regard to some relationship of probability? Okay, so let's see. If two events A and B are complementary, then probability of A plus probability of B is equal to 1. Okay, so that is correct. So that again, remember, we've seen it as probability of A is equal to 1 minus the probability of the complement of A. So just remember, then the one plus the other one will equal to 1. Okay, so if we so let's just check this one quickly out. So the probability of A, so let's keep it on the left-hand side. Let's bring that probability over. That is equal to 1. So we just showing again that the probability of a 1 plus the other one is complementary and will equal to 1. If two events A and B are mutually exclusive, yes, A and B is equal to 0. So that is correct. If two events A and B are independent, then probability of A divided by B is equal to the probability of B. Okay, so let's quickly check that. So we know if we say probability of A given B, that is probability of A and B. And that is divided by probability of B. And when I say if two events are independent, so that means probability A and B, we can work out as probability of A times probability of B divided by the probability of B. Okay, so we can see if probability A given B and the two events are independent, those two will cancel out the probabilities of B. So we actually are left with a probability of A. So that one is incorrect because it should have been probability A given B is equal to the probability of A. Okay, so we have now actually proven that. Okay, so you can use in the exam this formula. You don't need to prove it or anything. You can use the probability of A and given B will be probability of A, and the probability of B given A will be probability of B. Okay, but let's quickly look at, so that is the wrong one. Given probability A and B is equal to 0.4 and probability of B is that, if A and B are independent, then probability of A is equal to 0.8. Okay, so let's just so probability A and B, they tell us that is equal to 0.4. When they tell us probability of B is 0.5. So if we say then probability of A will be equal to the ant divided by 0.5. Okay, so we just wrote that formula out and then replaced with what we had, and then 0.4 divided by 0.5 will give me 0.8, and that is what they have also given us. So just when you get something like that, just write out the formula as we know it. So we know probability of A and B. So I would have started with probability of A and B, because I say it's independent, is equal to probability of A times B. Okay. And then we know they have given us the probability of A and B, and they've given us the probability of B. So then isolate probability of A, and by doing that, we would have said 0.4 divided by 0.5. Okay, so you're allowed to do it because they tell you A and B are independent. So then if I tell you that, you can assume that the probability of A and B is equal to the probability of A times the probability of B. Then let's just look at if two events A and B are complementary, like this one, then A and B must be mutually exclusive. Also correct, because you can see here the probability of the one plus the probability of the other one is equal to 1. So we don't have an and. So that means that the two will be mutually exclusive. Okay, so this question phrased nearly totally different from all the other questions. But again, it basically tests that you know independence. It tests if you know mutually exclusivity, and it tests if you know what complementary events is. So again, I think those are really the three things that would be important in any of the probability questions. I just want to quickly see how many questions are left. Okay, only 2 on probability, so we might just look at 1 or 2 others as well. I should have, oh wait, this one is exactly the same. So now you can see also not just in your sessions, that in your different assignments, even I got these two mixed up. So I think it's exactly the same. So this was, you can see, so definitely they used, this one was from one paper, this one was from another paper, so exactly the same one. So also why it is important nearly to see, and I have some hard copies that I will send you of previous exam papers that you have that. Okay, so let's look at another one. So again, one can see this was from a previous assignment. So consider the smoking habits table. what is the probability that a random chosen staff member is a light smoker, given that he is a junior manager? Where is junior manager? Okay, so light given, so they've written it, light given junior manager. Okay, so that is the probability of light and junior manager divided by probability of junior manager. Okay, so let's just get the screen back to size. And I just want to save that we have it. Okay, probability, light and junior manager. Okay, that's small numbers, only 3. Probability that the person is then a junior manager, so we need to get that total. So 4 plus 3, 7, 15, seems like 19. Okay, so that is 3 divided by 19, which is 0.1579. 0.1579. Okay, so there 0.158 if you round it off. Okay, select on this table. So what is the probability of heavy and secretaries? Okay, so probability of heavy and secretary is 0. So 0 divided by how many there are. So let's say there was 100, and let's quickly get the right number. So 4 plus 2 plus 3 plus 2. So that was 11. That was 19. 26 plus 10 plus 12 plus 4. That is 52. 18 plus 24 plus 34 plus 13. That is 89. 11 plus 6 plus 7. 24. So let's quickly get the total of that. 11 plus 19 plus 52 plus 89 plus 24, 195. Okay. Okay, so heavy smoker and secretary 0 over 95. So what can we say about heavy smoker and secretary? What are they? Okay, so if secretary heavy smoker is 0, there's a 0 probability. Then heavy smoker and secretary, they are actually mutually exclusive. Okay, so this is an interesting table because it's nearly the first time in a table that I've seen a 0. So that means that heavy and secretary, there's none of them. If there's none of them, they are basically mutually exclusive. Okay, so that is quite an interesting interesting one in this table. Okay, so they can also look at something like this. They've now asked now light versus or given junior manager. They could also ask is probability of secretary and medium smoker, is that independent or not? Okay, so they can, I've now just randomly chosen something. So let's check. Um, secretaries, there's 24 of them. So 24 over 195 times medium. So let's quickly add the medium. So it's 3 plus 8 plus 12 plus 34 plus 7. So we get that as 64. So 24 over 195 divided by 64 over 195. I get a very small 0.04. So let's quickly see. The other thing out to check now is to see if that and the 7, what that answer is. So 7 divided by 195. Round that off to 2 decimals. Huh. Okay, it's actually equal to 0.04. Okay. And that was tricky. So the two are the same. So secretaries and medium is then independent of one another. Okay, that's just weird that it worked out like that. Okay, so you can see nearly they can, and I just now looked at other possibilities and just said, so you can see they could have done the independence on this table. They could have asked mutually exclusive. They've asked the given. So any of these tables nearly, they can ask any type of question for you. So that is just nearly what I wanted to show tonight. On Sunday, we will go into discrete probabilities so that we can do that as far as we did tonight, that we don't go through these things too quickly. So on Sunday morning, we will do discrete, binomial, and Poisson. Okay, and then in a week's time, we will then do study unit 6. So we will just nearly continue with this, and then closer to the exam, I will get us another paper or two that we will work out in the sessions. Okay, so for now, we're just going step by step through the study units. To remind you again of everything that we have done this year, and then in that week or two before your write exam, we will go into much more detail, and we will spend more time in those weeks as well. Okay, so that is it for tonight, everyone. So I will again share the presentation on the WhatsApp group. I will share the recording, and